Correct.
Hi, all. I'd like to welcome you all to our virtual forum on industry water needs and the potential for water reuse. And my name is Lynn Dahman, and I am the Senior Managing Director for Purdue's Institute for a Sustainable Future. We have an exciting forum today, and just to let you know, we do have on our YouTube channel for ISF the previous webinars we've had over the last few years. And so I encourage you to check that out. And we will also be having another webinar next week in co-sponsorship with the Hoosier Environmental Council on PFAS and its uses and impacts in Indiana. So I encourage you all to check that out. And that is, I'm going to put
There's a link for that one on the final slide so that before people leave.
Okay, great. And I'll also put that link in the chat. So welcome you all, and I encourage you to check out our website and learn more about ISF. And now I will hand it over to Jill Hoffman, Director of the White River Alliance, to kick it off from their side.
Great. Well, I don't have much for you, group, except a welcome from our perspective. The White River Alliance is a nonprofit organization, and we head up water improvement and protection efforts in central Indiana, but some of our work also reaches statewide, including hosting the Indiana Water Summit. And we have been partnering with Purdue on these science and policy forums now for a few years, as you can see from the list on your screen. So just encourage you to stay engaged with all of that. These forums are a chance for us to take a deeper dive into some complex topics that sometimes we just don't have enough time for at the Water Summit, or we want to frankly have a bigger reach of folks since we do these virtually. So welcome, thanks for being here. Thanks for tracking with all of these important water issues, and hopefully we will see you at the summit again, which is usually held in August. So we'll get those dates out to you after the first of the year. But lots of good topics in the past, everything from wetlands to PFAS to flooding and on. But certainly the topic in front of us today is of growing importance as we try to not only balance water quality issues in the state, but also take on and think about water quantity issues as the demand for water in industry is continuing to grow. So really appreciate you all being here and taking the time to care about our water resources and getting engaged in both the science side of the work and the policy side. So with that, I'm going to turn it over to my colleague, Bill, who's going to introduce our great speakers for today, and we will see you during the Q&A session. Thanks, everyone.
Thanks, Jill. Thanks, Lynn. My name is Bill Bloomquist. I'm with the White River Alliance. Also, I'm going to give you a quick walk through what the next couple hours is going to look like. We're going to do this with 3 Q&A sessions interspersed. And this is truly a fantastic lineup of presenters, as you'll see. So I'm going to walk you through the whole program just in a minute, and then we'll come back to kick off with Professor Blatchley. So our opening 2 speakers, as you can see, Dr. Ernest Blatchley from Purdue University, and he'll be followed by Dr. Prakash Rao from Lawrence Berkeley National Laboratory. They will give information about what we know from a research perspective about wastewater reuse. Generally, that'll be Professor Blatchley, and then most common industrial applications of wastewater reuse, that'll be Dr. Rao. After we've had both of those, we'll have a 10-minute Q&A. Then we will go to 2 wonderful speakers from a more applied perspective or practitioner perspective outside of the academy. Nichole Morris with Cummins, a global manufacturing company that does reuse to meet some, or uses employs reuse to meet some of its industrial water needs. She will talk about how they do that as well as how they track it. And Eric Rosenblum, who is a consultant and former water utility professional with his own firm now, Envirospectives. So those 2 will speak. In between them, which may seem odd, but we don't want to take a break and Q&A session, but we will have been on for about an hour after Nikki Morris. And so we'll just take a 5-minute break at that point so you can just step away from your screen and come back after Nikki Morris and Eric Rosenblum. Then we'll do a second Q&A session. And then we go to Rob McCandless and Heather Tigwan. Say it for me one more time.
Tigwan.
Tigwan. So I'm sorry, I should have written it down.
No, it's
From
fine.
Stantec. And they are going to talk about public policy initiatives that can help facilitate greater uptake of water reuse. And then we'll have our third Q&A session after Rob and Heather. So I'm going to go back up here. But above all, I am delighted to introduce to you Professor Ernest Blatchley, goes by Chip. And he's our first presenter, and he's got slides to share. So I'm going to stop sharing and get out of the way. Dr. Blatchley, thank you.
Great. Thank you for the introduction. Can you hear me? Okay.
We can hear you
Some,
fine.
I can see some nodding heads.
Yes,
and can
we
you see
hear
my
you,
screen?
and slides are up. Yes, thanks.
Okay, great. All right. So let me just go to presentation. All right. So one more check. You can see what's on my screen. You're
Perfect.
okay. Great. Thank you. All right. So thank you for the introduction and the invitation to talk to you today about wastewater reuse. And really what I'm going to be doing in my presentation is just addressing some basic principles. So I think you're all probably familiar with conventional municipal wastewater treatment. This technology is about a century old, and it's pretty effective for removing or control more generally of what I refer to as conventional pollutants. Those include constituents that we quantify by total suspended solids or biochemical oxygen demand. They're also effective for control or removal of nutrients, especially nitrogen and phosphorus. They are effective for control of microbial pathogens, although we don't generally track pathogens, we track indicator organisms. And then lastly, if these systems are operated properly, they're effective for solids management. So these systems, as I said, are roughly a century old in terms of the technology that's used, and they are effective, as I've described. However, they were developed at a time where focusing on electrical power consumption was really not a priority. And for that and other reasons, they are among the largest users of electrical power right now. And generally, they were developed with minimal attention paid to resource recovery, which suggests both of those things, that there's opportunities for improvement. So just in schematic form, this is really what we are looking forward to in terms of how these facilities are going to be operated in the future. They will still have the requirements for control or removal of the conventional pollutants and perhaps others that I described on the previous slide, but they're going to be reconfigured to allow for a focus on resource recovery and reuse. And the resources where there are opportunities that are clear that can be taken advantage of here include energy. It is possible to develop these systems so that they are net positive in terms of energy rather than net negative. It's also possible to recover and reuse nutrients, especially nitrogen and phosphorus. But the focus of this presentation is going to be on recovery and reuse of water and recovery and reuse in a range of applications from irrigation all the way up to what's known as direct potabilization. So the wastewater or water reuse and recovery opportunities are going to require additional treatment beyond what has been used historically in these conventional systems, focusing on dissolved contaminants largely and microbial pathogens. So the endpoint for treatment in almost all of these settings is going to be governed by some set of regulations. Somebody's going to tell you what you must do in terms of treating this water. So as an example, I've illustrated some of the requirements that are stipulated in Title 22 in California, which dictates how wastewater reuse is practiced in California. So the treated water requirements are going to depend on the application. The requirements for water that's going to be used for irrigation of non-food items is going to be different than the requirements at the other end of the spectrum, let's say for direct potabilization. The focus of these requirements, as illustrated in this table, is on particles, dissolved contaminants, and microbial pathogens. And that's addressed, for example, in this column by the requirement for oxidation, which basically means the use of a biochemical process like activated sludge or something similar to that to address the dissolved constituents that are oxidizable. There's also a requirement for solid separation in some of these settings, and that's defined in this filtration column. The last row in this column represents, at least in this table, the most severe requirements. And those would be the requirements that would be applicable where the water has a larger likelihood of having human contact, either directly or indirectly. The technologies that are often, although not always, selected to meet these goals include membrane-based processes and UV-based processes. The UV-based processes, and I'll talk about these more in just a minute, include those that are used for disinfection, where UV is very effective, but also for advanced oxidation or advanced reduction processes. Focusing specifically on ultraviolet disinfection, which is commonly used. Again, the extent of treatment or the amount of UV that needs to be used in a given setting depends on the intended use. It sounds like there's somebody who's not muted. If you could mute, that would be great. Anyway, again, the extent of treatment is going to depend on the intended use, and it's also going to be influenced by the upstream particle separation processes. So this is a table of information that was compiled by the National Water Research Institute to define their recommendations for wastewater reuse applications where UV is used for disinfection.
This is Shalina.
Again, the amount of UV is
Rosenblum.
going to depend on how the water is going to be used and how the water is going to be treated prior to the application of UV. And the quantification of UV is defined by this thing that's labeled design dose. I'm happy to describe this more, but
I think I
basically
use the rewater at
for,
AOL.com, but if not, I use the Eric at Envirospectives.
if you could mute, please, that would be very helpful. Thank you. Again, the requirement is based on this design dose, which is quantified by testing using a method called biodosimetry. Again, I can talk about that more if you're interested, but the basic idea is that this test, biodosimetry, allows us to quantify the performance of a system. And you can see that for systems where there's a non-membrane filtration process, probably something like a sand filter that precedes you, the design dose would be 100 millijoules per square centimeter. Whereas if that same system was preceded by reverse osmosis, the requirement would be only 50 millijoules per square centimeter, roughly half.
Check balance and stuff. I was able to use the card.
Okay, I guess we can't mute on that end.
I'm trying to figure out how to mute all participants, and I'm not finding where it is, so I apologize.
Okay, all right,
Chip.
thank you.
I'm trying to mute people, and it's not letting me mute, so I'm trying to. I'm trying.
All righty, I'll just keep going, and I'll assume that if there are questions, you can ask me later. So,
Lynn,
yeah.
if you remove him as a panelist, temporarily. Okay, I think it's good.
Okay, thank you. So wastewater reuse is practiced broadly in the United States, although not all states are currently involved in wastewater reuse. The demand is, not surprisingly, highest in the water-starved areas of the country, and that demand has been exacerbated by climate change and in particular drought. There are, among the 50 states, 4 that are responsible for something like 80% or a little bit more of reuse. And perhaps not surprisingly, those are agricultural states that are, at least at times, water-starved, including Florida, California, Texas, and Arizona. So I want to talk about a couple examples of wastewater reuse. So this is a fairly extreme example that was implemented about 8 or 10 years ago in Wichita Falls, Texas. They experienced an extended drought that motivated them to pursue alternative sources of water. And one of the most reliable sources of water, at least in terms of quantity, is wastewater. So what they did was they implemented this pipeline that's illustrated in the photo on the left that transports their treated wastewater from their wastewater treatment facility to this other treatment facility located over here or illustrated over here on the right that includes membrane-based processes and UV-based processes. And then that water is discharged to a reservoir. That reservoir is the supply of water that's used for their potable water production facility. So that's an example of indirect potabilization, where they're basically augmenting an existing water supply with wastewater that's been treated to meet requirements that are stipulated and defined as being acceptable in the state of Texas. In California, more recently, they have implemented direct potabilization. Direct potabilization is where where a facility would treat wastewater, or they start with wastewater and treat it to the point where the treated water could be directly injected into the water supply system. So this was motivated by an extended period of drought, especially in California, but more broadly in the Southwest. Also by the fact that California and a number of these other states that are water starved are experiencing increasing urbanization. Their urban populations are increasing. Also, there's also substantial demands for water use in agricultural settings. So the need then exists to rely on water supplies that were previously viewed as unacceptable. Among those are wastewater. And so municipal wastewater, again, represents a reliable source of water. And the trick really is to treat it so that it can be used in the intended application here in direct potabilization. So this is not unique to California. There are similar approaches that have been applied successfully elsewhere. So briefly, the membrane-based processes are described on this slide in schematic form. So there's a range of pore size openings that exist in the various membranes that can be used in these settings. And there's a variety of separation mechanisms that range from size exclusion to electrostatic separation processes. So the basic idea is that these processes, depending on the membrane that's selected, can allow for very effective physical separation of large molecules and microorganisms. And generally, these systems are going to precede a disinfection system like UV. So again, schematically, what this image in the lower left illustrates is that sort of the ability of various membranes to separate constituents from water. So a microfiltration membrane is relatively loose. It will allow for rejection of bacteria and suspended solids, but smaller particles like viruses or ions that are present within the system will pass through the membrane. If we tighten up the membrane going to ultrafiltration or reverse osmosis, progressively we're going to start rejecting more and more, or in other words, smaller and smaller constituents that are present in the water supply. Disinfection, the requirements for disinfection, like the requirements for other forms of treatment, are again going to depend on the intended uses. And generally, the disinfection requirements become more stringent than those that we would observe with conventional wastewater treatment, where you might be discharging the treated water to a receiving stream. For a number of reasons, UV is often the preferred mechanism for disinfection. Those reasons include UV is a broad spectrum disinfectant. It can be very effective against virtually all pathogens, including viruses, bacteria, and protozoa. There's less disinfection byproduct formation than with the common chemical disinfectants, including chlorine and ozone. These systems tend to have smaller footprints than chemical disinfection systems, and they have lower energy requirements than chemical disinfection systems. And UV disinfection systems that are used for wastewater treatment or reuse generally will involve these open channel designs that are illustrated in the images on the right. UV can also be used to go after dissolved constituents, and it can be used in a number of different ways. So I've illustrated 3 different ways that UV can be effective for degradation of dissolved chemical constituents. The first is direct photolysis, and as an example, I've illustrated the compound N-nitrosodimethylamine, or NDMA. NDMA is a very potent carcinogen that is present in a number of water supplies. And because of its chemical and physical characteristics, it's difficult to remove from water. For those and other reasons, it turns out that UV photolysis is oftentimes the method of choice, because UV radiation can split this molecule and degrade it to a non-toxic form. UV can also be used to promote the formation of reactive intermediates, including reactive oxidants. So here I've illustrated 2 examples of so-called UV advanced oxidation processes. The first involves hydrogen peroxide. When exposed to UV, that molecule will be split to yield 2 hydroxyl radicals. And the second involves hypochlorous acid, which is the most active form of chlorine. Likewise, HOCl will be split by ultraviolet radiation to form a hydroxyl radical and a chlorine radical. These radicals are very powerful oxidants, and they can be very effective for degradation of reduced contaminants that include endocrine disrupting compounds, pharmaceuticals, personal care products, and other constituents that are oftentimes of concern in wastewater reuse applications. And then lastly, UV can also be used in what's known as an advanced reduction process. Here again, the idea is to use UV to promote the formation of a reactive intermediate, but in this case, the intermediate is going to be a powerful reductant. And the reductant that we specifically focus on in these ARP processes is the hydrated electron. That is the most powerful reducing agent, and it's very effective against highly oxidized contaminants, notably including compounds in the category PFAS. So to summarize, wastewater reuse is practiced widely in the United States and elsewhere. It represents a reliable source of water that can augment existing water supplies. The finished water quality requirements depend on the intended uses, and these systems often are developed based on membrane-based processes, perhaps involving a combination of reverse osmosis, ultrafiltration, and microfiltration, as well as UV-based processes that can focus on disinfection, oxidation, or reduction, or a combination. So thank you. And at the end of the next presentation, I believe there'll be a Q&A session.
Exactly. Thank you so much, Professor Blatchley. We really appreciate that. That was a perfect background and overview of wastewater reuse and the technologies and the science behind that. And we're going to follow that, as I said, with a presentation. We're so happy to have Dr. Prakash Rao from the Lawrence Berkeley National Laboratory, where he's in the building systems department. And he is going to talk about, I've seen research that Dr. Rao co-authored about most common applications in industry of reuse. And he's going to talk about that as well as a few other things in terms of industrial applications of water reuse. Dr. Rao, you should be able to screen share your slides. If you have any difficulty with that, I have your slides and I can run back up. Nope, there you are. We can see your opening slide.
Great. You all can hear me okay?
And we can hear you just fine. Thank you so much.
Fantastic. All right. Thank you, Bill, for the introduction. Yes, as Bill mentioned, I'm Prakash Rao from Lawrence Berkeley National Laboratory. If you don't know us, we're one of the 17 U.S. Department of Energy national laboratories. We're located in Berkeley, California. And I'll talk to you today a little bit about industrial water reuse applications. And as we use the word industry, I know it can mean different things to different folks. So I'll focus primarily on manufacturing. So not thinking about agriculture or data centers or things like that, but focusing specifically on our manufacturing in the U.S. So in that vein, brief outline of the talk here. I thought it'd be helpful to talk a little bit about how our manufacturers use water, and also close that out with a little conversation a little bit on water scarcity and how that's a little bit of a motivator for some of the actions we see manufacturers taking. Then we'll talk about some cost-effective water reuse and manufacturing water reuse and efficiency opportunities, and then we'll then segue into some additional potentially cost-effective reuse opportunities that are seemingly difficult, but when you look at what manufacturers already do and the complex systems they already deal with, it could be easier than we think. So, all right, so let's start with how manufacturers in the United States use water. So this is from the United States Geological Survey. Every 5 years, I believe it is, they release data on water use in the United States. The newest data should be coming out pretty soon, but for the time being, we're kind of in the waning days of the old data set. So the old data set, which goes back to 2015, tells us that the United States withdrew 322 billion gallons per day of water for its all purposes. Manufacturing, it's specifically was about 20 billion gallons per day. So 20 billion gallons per day represents about 6% of all water in the United States withdrawn daily is for manufacturing purposes. If we look at on the right here, the circle charts, of that 19.7 billion gallons per day going to manufacturers, where is it coming from? So the vast majority of manufacturing of water supplies for manufacturers is self-supplied resources. So that's their rivers, their lakes, their groundwater resources. They've gained permits and they're allowed to draw directly. So the 60% of manufacturing water is from surface water resources and 15% from groundwater. So and the remaining 25% is from from domestic municipal water plants. So within that, some of it's saline water, but almost vast majority of that is fresh water. Vast majority of the 19.7 billion gallons. And then, manufacturing is not a monolith. It's a very heterogeneous industry, whether you're making semiconductors to paper, it's wildly different sort of processes and water use characteristics. So it might be a little instructive to think about, well, who are the biggest users of water? And when we look at it in that vein, we find that there's 5 sectors that constitute 94% of all manufacturing water use in the United States. And on the left here, you'll see those sectors: food, paper manufacturing, petroleum refining, chemicals and petrochem industry, and the primary metals industry. Within that, and I should maybe draw a line here. So the USGS data tells us essentially how much self-supplied water from manufacturing. All the other numbers you're seeing here is analysis we did, bringing additional data points to try to understand how much public water supply goes to industry, and within the sectors, how is it used, and within those sectors, which I'll get to, what the purpose of the water is. So we extracted the data and estimate that these are our top 5 sectors. Within those 5 sectors, how they use water, we've extracted kind of based on permit data and other use characteristics, that for most industries, or for petroleum refining, chemicals, and primary metals, the vast majority of the water is for cooling, condensing, and steam. So this is a lot of once-through cooling for systems that need it. But then in the paper and food, there's a lot of processed water use. So this is for in-product use, rinsing, those sort of things, with a lot of cooling and condensing as well. One thing I want to point out, as we talk about, often manufacturing, when we talk about water, is kind of grouped with commercial, industrial, and institutional, CI and I, you might have heard of. I want to point out why it's kind of important to kind of draw a distinction there. If you look at sanitary and domestic use, which is larger in those institutional and commercial facilities, it's really not too big a deal in manufacturing. This is like your potable water for drinking, restrooms, that sort of thing, showers. Whoops, wrong way. All right, so if we break down then kind of the water use, getting back to the manufacturing level, not at the sector level, and where it's being used, we'll find that in some states it's far more predominant than others, and in some counties it really is the major water use. So side note, I've presented these slides before, and I always get to talk about, well, look at Indiana. Indiana is the #1 state in water use, and now I get to present it to folks from Indiana. So it was kind of a full circle moment. But Indiana is the #1 user in manufacturing water use by our estimates, and followed. And in fact, if you look around the Great Lakes region, you'll see a lot of water use, and that's just reflective of sort of historic the amount of industry you all have along the Great Lakes, particularly primary metals and some of these really heavy water use industries. So it follows, right? And then the next area that you see a lot of water use is the Gulf Coast, right? We know there's petrochem industries, oil refining industries, those are tremendous water users, as we saw previously. So you're seeing states like Indiana, Louisiana, Texas emerge as the top 3. What's really interesting is when you can get down to sort of the county level, it's not that, for example, to stay on Indiana, it's not all of Indiana, it's select counties in Indiana, and those along Lake Michigan. Lake County and Warwick County are the 2 largest water users for manufacturing in Indiana. Whereas, I'm not in the southeast corner of the state, it's not as predominant. Similarly, in Texas, it's not West Texas. It's specifically Brazoria County, where there's folks like Dow and some of the other petrochem industries, and you see that in the data. So in these counties, it can be as much as 75% of the county's water use. 6% nationally, 75% in some counties, which gets to the regionality importance of the water use, right? So national numbers, are instructive, but they don't reflect maybe the urgency of water use and the need for water management and water efficiency. The map on the left, you guys have probably seen a million times. I pulled this from the most latest drought monitor from the University of Nebraska's website. But you could here on the left, it's showing drought, and very logically, deeper red means more drought. So I want to I like to show this with the point being that scarcity, and this is physical scarcity, is not something that's just a Western United States problem, which we kind of often think of it as, oh, well, it's California, Nevada, Arizona. Certainly there's drought there, but if we kind of draw our eyes to the middle of the country, around Montana and the Dakotas, you'll see extreme drought. Consistently within the Great Lakes region, whenever we look at these maps and long-term trends, the Great Lakes region is quote unquote under drought. And the Northeast, a place where I grew up, and we never talked about drought, but every week I call my parents and they're talking about drought, and there's wildfires in New Jersey and things like that. So, and as you see in the New York City metropolitan area, they're in what would that be? Severe drought right now. The SL stands for short and long term, so it's not just a flash in the pan. So we looked at longer term water stress indices. Specifically, we looked at a metric that looks at human water use, which is for any purpose that humans kind of dictate. So it's not just for our homes, but for our manufacturing, for our food. If that rate of water use is greater than the natural replenishment rate of water in the region, we took a very sort of like, black and white and said, that's extreme stress. And we looked at where water is being used by manufacturers, overlaid that with counties that where there's more water use than what's naturally replenished. And you'll find that sectors like primary metals, which is our steel mills, our aluminum plants, 35% of their operations is in water stressed areas. Fabricated metal products, transportation equipment, 10% for the top three. So the locality and the regionality really matters. So then kind of getting to what can we do about it, and that's where we get to like water reuse, and efficiency, which I'll present here as two of our best options for kind of making our manufacturers more resilient to water issues, and kind of get into some of the opportunities. But this cartoon here shows how manufacturers use water, and so kind of falling left to right, you can have three common sources of water. Kind of talked about this already, but it's surface water, lakes, rivers, groundwater, or your municipal plant. New point here, though, is on the left, just a reminder that they all have to share. The manufacturers have to share with the local industry. So there is an allocation problem, and there is a finite resource. Once the water comes in the plant, it might need some on-site water treatment. For example, a semiconductor plant's going to have to take that water down to almost distilled level, 0 ppm, nothing in it. Whereas to Professor Blatchley's point, some of these facilities, don't even need potable water, right? So they could be using this it's not drinking standards. So it's a gamut. So some may need some on-site water treatment before they use it, some may not. There it generally goes into the processes or the cooling systems, the ancillary services, such as boilers and steam or chillers needed to make product. That's number 4 here. And as far as water reuse, there's a couple loops that you can have. You can have reuse at the point of use. So a process could be recycling its own water without actually ever going to any sort of treatment or any sort of anything like that, like a closed loop system or something. Or the water could leave the process side, and there's a few fates. It could be treated on site a little bit maybe before it's disposed of back in the river. Or maybe it needs to be treated on site before it can be sent to the municipal plant because it's not clean enough to be sent there. Or it can be treated a little bit or to a quality where then it can be looped back into the plant, to the process and be reused there. So that's number 5. There's also opportunities for or situations where it's not treated and the water can be directly discharged. Think about your once through systems, once through cooling systems, or maybe it's just sent directly to the municipal plant. And finally, a couple of sources that aren't probably too relevant to our conversation today, but are critical for some of the scarcity issues and thinking about water's consumption. So we have evaporative losses and water embedded in products as water is going to leave the watershed's boundary. So we have those as well. Now, if we think about, okay, how do we use water and for manufacturers, recognizing that scarcity can often be a driver for water efficiency or for water management practices, what are our best options for hardening our supplies, adding more supplies so that for our manufacturers, so that if there is a drought, they're well covered. There's redundancy. What we looked at some of the most common options and aligning with sort of what others have found as well. Really, if you think about water efficiency and reuse as an additional water supply option, just like as if you dug a lake and started collecting rainwater, it is by far the cheapest option from our analysis compared to anything else you could do. So in our analysis, we looked at something called the levelized cost of water, where we looked at if you're going to do a water intervention, maybe it's from building a desal plant, let's say, to an efficiency measure or a reuse measure. And you look at the total operational capital cost, maintenance cost over the lifetime of it. Look at how much water it produces or saves, which we're going to kind of say if you save water, that's kind of like producing water, right? Because you're leaving more water for the next person to use. How much is it cost per unit of water that you saved or generated? And as you see here, that's the levelized cost. It allows for sort of comparison, and that's what we're doing here. Above the dashed line, you're going to see some of the efficiency and reuse options, with reuse options highlighted with arrows, these blue arrows. And below the line, it's not our data. We pulled it from the literature, but it's the levelized cost for new water supplies. So as you can see, new water supplies, something like stormwater capture, we're looking at $581 in terms of capital and operations and maintenance costs over a lifetime of the system. For every 1,000 cubic meters of water generates $581. If we come to something, a reuse option, and I want to kind of suggest that reuse can be something just as simple as going away from those once-through cooling systems, which are so predominant, and moving to cooling towers, evaporative cooling towers, which allow you to reuse the water multiple times until it ultimately needs to be disposed of because it's built up too much contaminants. As an action like that, for every 1,000 cubic meters of water you save, it's only $24. So you're looking at a 20x decrease in cost. I want to point to this, what's seemingly an outlier here, which is negative $4,000 per cubic meter. And that's a very, a lot of steam use in manufacturing plants. When steam goes out to the plant, it loses its heat intentionally, and oftentimes it condenses and you get a condensate. Many manufacturers do return it back to the boiler. Some don't, and many don't return it to the extent that perhaps they could. But when you look at capturing of that condensate, you can't capture all of it and return it for technical reasons, but if you can capture 60-70% of it and bring it back to the boiler and reuse it to generate steam, you're looking at a savings of $4,000 per cubic meter of water. Why is it so high? If you can pair your water reuse or your water efficiency with energy savings, then you start to really see a reduction in operations and maintenance. So a lot of that $4,000 is a natural gas savings from not having to heat the water up as much to take it up to steam temperature. Imagine I'm heating lake water at 60 degrees, or I'm heating condensate that's maybe at 180 degrees. There's a lot less energy required for that. Other options not shown here because we didn't have the financial data, but we think there's significant opportunities. Increasing cycles of concentration in cooling towers. So cooling towers have something called the cycles of concentration. We're basically looking at the amount of contaminants that within the cooling tower water, the conductivity of it, and when it reaches too high a value, they'll blow the water down and kind of refill or blow some of the water down and add fresh water to kind of get the conductivity back into line. Often you can increase these cycles of concentration, kind of push it a little bit more on the conductivity without any sort of issues. So if you have a cycle of concentration of 2, you can go up to 3, 4, 5 is what the Department of Energy is often recommending for their own cooling towers. Cascading rinse waters. So if you're rinsing vessels or you're using it for production, keep moving that to something, go from cleaner to dirtier to dirtier to dirtier. We went to a food plant and it wasn't cleaner, it was stinkier to stinkier to stinkier. So they rinsed out their salt vats. It was a spice manufacturer, all the way down to the last thing they did was the garlic, because they don't want the garlic rinse water mixing with the thyme rinse water, and because that would taste bad. So there are these and kind of joking, but there are practical limitations to this too, right? Manufacturers aren't just looking at the quality, but they're also looking at things like taste, odor, and making sure it doesn't impact product quality. So as we think about water reuse, that's another thing to think about. It's not just quality, but it's also these other factors.
Dr. Rao, I know you only have 2 more slides, so I just want to mention the time.
Wrap it. Sure thing.
Wrap us up.
Yeah,
Thank you.
I'll push through here. So deeper look at water reuse. So those are some of the simple options. We also looked at, as you noticed, water manufacturers do treat their own wastewater and then oftentimes to dispose of it back into the river or the lake where they got it from. We looked at those discharge permits and we looked at the water quality requirements for their production processes. And one thing you see is a lot of manufacturers are actually already treating waters to levels sufficient for their processes. So I want to harp on the primary metals industry right here, largely because of how representative it is in Indiana. We've indexed things. So if you're below 1, that means your water that you're discharging to the river is sufficient in water quality along the constituents we looked at to be reused in your processes. If it's above 1, that means it needs further treatment. But as you can kind of see on chlorine, total dissolved solvents, total suspended solvents, solids, and hardness, as represented by calcium carbonate, waters are being treated to sufficient qualities already for reuse. So the suggestion here is that some of the complex water reuse options might not be so complex as you might be manufacturers might be already doing the hard work of treating it back to levels that they can reuse it. So just to close up, sorry for going over here, but water is critical in manufacturing, used in a lot of ways. Cooling and steam are the most largest users. Where manufacturing coincides with scarcity, alternate supplies could be needed, and the most cost-effective are reuse and efficiency. And some of the more complex opportunities may not be so complex when you think about what manufacturers are already doing and the systems they handle. That's all I have. I guess not questions now, or I guess questions collectively.
Exactly. We're going to go to questions for both Dr. Rao and Dr. Blatchley, who gave us these wonderful overviews, first of wastewater reuse, the science and technology of it, and then of industrial applications of reuse. We're grateful for those. For all of you attending, there is a Q&A function. If you just move your mouse around the bottom of your screen, you'll see the Q&A button pop up. You can type questions in there during the presentations or even now, and I will keep an eye on that. And while we're waiting for questions from our attendees, I'm just going to start off with just one that just sort of, I hope, captures something from both presentations. So this is to both of you. Suppose you were in a conversation with somebody and you were talking about wastewater reuse as an option for water supply. And they said, oh, well, we don't need to go to anything that exotic and expensive. We'll just, keep doing what we've been doing in the past, or go get more water from somewhere else, or try to find other ways to produce water. It sounds like from your presentations that you would have a kind of a rebuttal to that question. Can I start with you, Dr. Blatchley, and then Dr. Rao?
Yeah, I think historically people have not considered wastewater reuse or water reuse in a broader sense. I think it's really just sort of been viewed as we're going to extract water from a local supply, whether it's a lake, a river, or groundwater formation. We're going to use it and then discharge it presumably appropriately to the environment. And so the reuse part of things has not, I think, been part of the thought process broadly. But it's also clear that there's a number of, let's say, practices that we have followed historically that are not sustainable, and that we need to consider changes to how we're doing these things. So,
thank you. Dr. Rao, did you want to talk about that as well? Especially
Yeah.
in terms of your cost analysis?
Yeah, and the cost analysis, exactly. One thing we've observed, and this is not survey-wise, but just in discussions, that often, manufacturers can get this manufacturing recycled wastewater at a lower rate than a fresh water or potable water. So that's every gallon you're using, you're saving a little bit off the top right there. I would point to the other place I would point to is sort of optics of things. So we had one manufacturer kind of tell us, look, no matter what happens to the water in the watershed that we operate in, we're going to get blamed. So there's you should be proactive. So if you're doing things like purple pipe networks or something like that, I think it's showing your commitment to sort of water stewardship, and that goes a long way. And finally, kind of in Southern California, I think it's the West Basin Water District. They have a purple pipe, so recycled water, wastewater facility that serves a few of the refineries, and they have long-term contracts where the utility knows that refiner's not going anywhere, and they're going to buy this much water, and the manufacturers have no problem using it. They're all refiners. So there's a really great symbiotic relationship between the wastewater plants and the manufacturing facilities. It's been very successful for many years. And one thing that helps with on the municipal wastewater side is it gives them a constant load for their wastewater. One thing we hear is some of these municipal wastewater plants, sometimes they have to dump because maybe the golf course doesn't need the water right now. But the manufacturers always need water. Many of them are 24/7, always going. And so it's a really great symbiotic relationship. It can be cheaper for the plant. And I think in terms of sort of corporate stewardship of water, I think it's a really great thing to kind of a feather in your cap if you were to do it.
You both have teed up our next two presenters so elegantly. Nichole Morris is going to talk about the application of water reuse within manufacturing facilities in a worldwide firm, and Eric Rosenblum, among other things, is going to talk about that utility-client relationship that you just kind of touched on, Dr. Rao, where there are opportunities for real win-win arrangements between large-scale year-round water users and water suppliers who might, in fact, be producing recycled water. So I think in the interest of time, and because there aren't any questions in the queue right now, I'm going to go ahead and reintroduce Nichole Morris, who is the Global Water Resource and Sustainability Lead for Cummins Incorporated. We're just delighted that you're here. And our organization, the White River Alliance, hosts a podcast called The Collective Tap, and you're welcome to go find the Collective Tap podcast series. And that was when I first heard Nichole Morris talking about what they do at Cummins with water reuse. And as soon as we were putting this forum together, it was like, how do I get a hold of Nichole Morris? So thank you so much for being with us. You should have access to share slides if you have some, and well, I know that you have some, and we are looking forward to hearing from you. So Nichole Morris, thanks for being here.
Absolutely, and I appreciate the introduction and the invite. I'm going to try to share here. You let me know.
Coming up. Yep, we are looking at your screen.
All right, so I'm going to go through a little background for Cummins. I've been with Cummins for 24 years, always in the environmental role. So we'll go through the first part of this pretty quickly because it was covered very well by the previous two panelists. But our founder believed that in order for us to be sustainable and prosperous, we had to work with our community. And so that it's part of our core relationship with our community to be a sustainable citizen and be responsible. And we understand that when we're looking at all of the different intricacies of manufacturing, natural resources are in the core, and they link everything together. And if we don't have sustainable resources, we're not going to be able to be prosperous and sustain. So we started looking at this a long time ago, and we started looking at risk. There's a question I see.
Oh. Mary, your hand's up. Did you mean to have your hand up, Mary Atkins? If you meant to have your hand up, please go ahead and ask your question. If you didn't mean to have your hand up, there's just a lower hand button that you'll see at the bottom of your screen.
Okay, I'll continue and we'll see.
Yeah, please go ahead.
Okay, so we started looking at water risk back in 2007 and earlier. We started having issues at some of our sites with droughts and not having enough water. Hang on. And so we looked at how we could set goals and what we needed to do. And so we started tracking water stress across the country and across the world. And if you look at this map, this is what we saw when we started well, this is actually the one that we saw when we did the last set of goals, but we were looking at these maps all along. And so you can see that the water stress is prominent in the US and in a lot of countries where we operate. We operate in 190 countries over the world, and a lot of them happen to be in these areas that are red or extreme risk. And then when you look at the data, there's suggested that by 2030, there's going to be a 40% water deficit, meaning we're extracting 40% more water than we're replacing. So we were wondering how we could get ahead of that. So we started looking at what our goals and strategy were. So we set our first external goal in 2014, and that goal was to reduce our gallons per man hour by 30% by 2020. As we started the journey and looking at water, because we really hadn't looked at water that much before, energy had been the primary focus, so we weren't really looking at water. So we started metering, we started understanding more where our water use is coming from, looking at water balances across our facilities, and we noticed that we had a lot of easy things we could do. So in 2017, we had already exceeded our goal, so we modified that goal to a 50% normalized reduction. And then 2020 came, we had achieved our goal. We actually achieved it. We were at 53% reduction gallons per man hour. And so in the meantime, during the 2018-2019 timeframe, we're working through what our new target's going to be, because we're already coming upon 2020. So we were looking for 2030 goals. And we decided to shift to a more science-based target, and we shifted to an absolute reduction of water consumption of 30% from our baseline of 2018. And we're trying to get ahead of that 40% deficit. And we have another portion of our company that works on corporate responsibility, and they work on water neutrality projects where we provide water to the community. And that program has already exceeded our total consumption as a company. So we provide more water globally than we use globally already. And now we're looking at doing that at a more regional level. So that's where we assumed we already had that 10% covered. We would cover the other 30% through our own facilities and manufacturing. So we developed a water hierarchy, and we deploy this for how we choose to manage water. And you'll notice that my terminology is going to differ from the previous panelist a little bit, because to make it clear, we had to differentiate between reuse and recycle. So reuse to us is when we recirculate water within the same process with or without treatment. So this could be we're recirculating in a cooling tower, we're going through staged wash tanks, we're filtering it or something, but it's going back into the same system so that it's being reused. And then recycling to us is when we recycle water into another process. So that would be, for instance, we take wastewater, we clean it up, we use it for toilet flushing, or we use it for cooling towers or whatever. Now, you'll also notice that if you look up a couple of more rows in the hierarchy, there's an alternative, what we call alternative. That's an alternative water source. That's not fresh water. Now, this is where we focus on capture of condensate, capture and boiler, any kind of blowdowns or anything like that from our systems that, perhaps already have a high quality of water that we can use without any kind of treatment or anything else. And we would just use that as an alternate source. So we have several facilities, and I don't even know the millions of gallons right off the top of my head because I focus solely on the recycle portion for this. But we have several facilities, and we capture and use several million gallons per year of these alternate water sources, mainly condensation from HVAC systems, from chillers, from air compressors, things like that we reuse. And most of the time that's reused in a machining process or a cooling tower. So when I start talking numbers and stuff, we won't be talking about that. So what I'm really going to focus on is just what we call recycle, which is reuse of a wastewater. And we're trying to push more for reuse at the source, at a source, because it's usually cheaper, it's easier, and it usually helps the quality of the process also. So wastewater recycling in practice. So we currently have 15 sites that report that they reuse wastewater. And this means that they either already had a wastewater treatment facility or some sort of wastewater treatment where it was a commingled mixture of wastewater coming to a facility, being treated and discharged to a municipality or some third party source. And so we looked at, how can we use this water? Because as previous panelists said, it's a constant supply. In many cases, it's already a quality where we can reuse it in a particular process. So how can we redo that? How can we reuse that? So when we set our goals in 2018, when we set them for 2030, we set 3 critical X's. One was focus on irrigation, one was focusing on fire system protection, water recycling, and one was focused on wastewater reuse or recycling. And 3 of our large manufacturing facilities have, and they're pictured here, have they have the largest footprints, and they're recycling over 22 million gallons per year of wastewater right now that goes back in their processes. The increase from 2018 is 1,000%. And total, those 15 facilities together are achieving more than 39 million gallons in 2023 as a reuse. The first one I'll talk about, this is KEP, or Cuthrud Engine Plant in India. They are the largest reuse facility at over 8 million gallons, and they have 100% recycling of their wastewater. All of our India facilities have a 0 liquid discharge goal by 2030. So all of our facilities in India will be recycling 100% of their wastewater. And the ETP and STP is their terms for effluent treatment plant, which means industrial treatment, and STP is sanitary treatment plant. So they're actually recycling both. They already had an existing system that had the equalization tanks and aeration system, sort of a typical treatment system. And then we added an ultrafiltration system to be able to meet the quality that we need in manufacturing. All of the reuse is in non-contact manufacturing processes, so it's no public contact, so there's no need for disinfection. But it does go through the intense ultrafiltration process, and you can see they're really proud of it. They have the little bioassay fish tank that they show that how clean their wastewater is. So they're really proud of that system. And like I said, they're reusing about 8 million gallons a year from that system. And by the way, Cummins uses 972 million gallons per year globally of water. Now, this particular project is in Rocky Mount, North Carolina. It's a water hub, and it uses sort of a different type of process. The previous plant had an industrial system, which was mainly physical chemical separation, and then they had an aeration system, which was a typical aeration basin system like you would see in a municipality. And in place of the aeration system, now they have installed this water hub, which uses, underneath this building that you see, it's a chamber of membrane material that allows for densely packed root growth as well as biological growth on that membrane. And so through hydroponics and that bacterial treatment, it gets the same treatment as their old aeration basin, actually better. And then it also goes through a series of filtration and reverse osmosis, and then it's reused. They're at about a little over 7 million gallons a year reuse. Right now, they're reusing about 70% of their wastewater. And same thing, it's all being used in their cooling tower. Their cooling tower is their largest load on the facility. And this facility had already previously installed condensation capture and everything. So this was the next step for them. They have the capacity to go up to, I think, 10 million gallons with this particular system. This one is in Jamestown, New York. Sort of the same system. They're an engine plant. They had a typical aeration basin. They kept that system and then they added to it a membrane bioreactor and reverse osmosis canisters and ceramic membrane ultrafiltration. And now they're at about 7 million gallons annually. And this facility is capable of 12 million gallons. They reuse the majority of it in processes. The same thing, non-contact processes. We don't have any reuse right now where it's an employee contact process. Everything is in a non-contact form. And we these are the two largest implementations we have in the United States. As I said previously, India has several that are coming online now. And we are seeing the ability in China to actually purchase non-potable water from the utility. We have not started that process yet. We would prefer to implement it within our facilities first and then do that. But that is an alternative for us, is to, in China, to be able to purchase it from the utility as well. So things that we learned. Submetering is a wonderful enabler. You can't fix something if you can't measure it and you don't see it. So submetering is a great thing to get established up front. Understanding all your regulatory requirements up front before you start the process, so you know exactly what you need to do. Prior consultation with the local utility is beneficial, not only from a sort of a community service type thing. It's also, in some cases, our facilities are the largest consumer of water at a facility and for a utility, and us migrating to another source can potentially harm the utility in terms of profit. So we've found that it's better to talk to them up front and explain what we're doing and get buy-in at the beginning. And if there's anything that we need to do to help them, we can do that as well. And this next one is very important. Understand what your true water quality needs are in all of your processes. Because if you do not know what your quality needs are, if you're making the assumption that you need potable water in a machining line, or if you're making the assumption that you need potable water in a washer, that may not necessarily be true. And this takes a lot of work to really understand what that quality need is in your process. So understand that up front. That tells you how far you have to go in your treatment process. And it also can highlight areas where you can reuse water just as it is. Plan for worst case when you're building systems. Look for failure modes, do a failure mode analysis, and plan for it. When you're in an industry and you're manufacturing, we run 24 hours a day, 7 days a week. You don't have time for a wastewater treatment plant to go down. So if you have to do equalization tanks, or if you have to do parallel streams, or whatever you need to do to make sure that you can maintain your facility all the time, you need to make sure you plan for that at the beginning. Plan for flexibility, like I said, dual trains, anything you need to do to be able to switch back and forth to be able to maintain production. And then here's another one, because a lot of leadership doesn't understand this and it's really hard. There is no one system fits all. In a lot of cases, our leaders would like for us to say, well, we're going to use this type of facility at every engine plant, this size, and we can bulk buy, and you can't do that. The intricacies of wastewater and the parameters that you have to treat for and the quality needs are not such that even if you're building the same equipment, you can't necessarily use the same package plant to meet those needs. And then also, this is really important, establish a culture of reuse at the source, so that you break the culture of, well, we're going to mix all of our wastewaters together and commingle it, and the wastewater treatment plant will figure out what to do with it after that. You move it back to the point source and start at that process and try to reuse as much as you can at the source before it goes into a commingled system. So I think same as before, the questions are going to be after the next panelist. So
you're exactly right. Nichole, fantastic. I mean, to hear from our researchers and then to hear from our practitioners is just such an advantage, and appreciate it, and appreciate all the leadership that you have devoted to this topic. We are going to take a 5-minute break. This is just to avoid any international human rights violation. We're going to let you get away from your Zoom screen for 5 minutes. We are going to resume at 20 minutes before the hour and hear from Eric Rosenblum. So we'll see you all in a few minutes. Thanks. Okay, respecting the fact that that was a really, really, really short break. But we did want to at least take a short break.
Hey, Bill, can I ask you a quick question? Because
Yes.
I got a comment that that the panelists were not able to put in a question in the Q&A, and I'm not sure why. So I'm wondering if someone who's a panelist could try to put in a question and see if it works now.
I don't know about the panelists. I actually,
I mean, the attendees, for the attendees.
I received an email from an attendee saying that they weren't able to use the Q&A function.
I am not sure why that is true. I'm looking into it.
Yeah. Well, I just wanted to see if there was anything that we needed to do about that. But for the sake of time, what we're going to do is move forward. And we are thrilled to have Eric Rosenblum, CEO of Envirospectives, also a person with a previous utility professional experience. And I think we may have to unmute you, Eric. Oh, there you are. You're unmuted. We should be able to hear you.
Terrific. And thank you all so much for including me today in this fascinating webinar.
It's great to have you.
Really appreciated all the presentations I've heard so far. I'm going to put a few slides on. And really, this is a great a setup to hear from Cummins and Ms. Morris about all the great work they did. What I appreciate from this is that this is a great example of what a motivated company can do with a desire to use water more responsibly, and you know, with the technology and the resources to do something about that. So let's see. Okay, everything good with the slides?
Yes, absolutely. We can see you and we can hear you.
Terrific. So Dr. Blomquist asked me to essentially summarize a chapter in a book that we published in 2021 called Sustainable Industrial Water Use: Perspectives, Incentives, and Tools, in which I drew on my experience as the former manager of a water recycling utility in Silicon Valley to talk about how utilities can support the desire of companies to use water more responsibly, looking at the distinction between the public benefits and the private costs, the barriers to sustainability, and how we can incentivize reuse. Before I dive into that, though, I wanted to give a little bit of background. The book that we published, we did in part because we recognize that while there's all kinds of great technology available for producing water, you know, for recycling or treating wastewater to remove the pollutants, what we lacked really was the political will and a sufficient collaboration amongst all the parties. What I mean by that is we recognize that industrial water use in particular is not solely the responsibility of the companies. While there are examples like Cummins of companies that take their social responsibility very seriously and invest in improvements to their water use, the fact is that it takes everybody working together to make that happen, not just the industry, but the utilities, the government policymakers, the banks, the financing institutions, the NGOs, and even the public as consumers of the products. And they all have an important role to play. So we wanted to highlight that. And you'll notice that the book, it includes articles from 60 researchers and practitioners and NGOs around the world to talk about their role in that. It's available online, by the way, as open access. The other thing I wanted to share from the book was that my colleague Cheryl Davis identified 4 different types of companies. The early adopters, and certainly we'd see Cummins in that group, who see the long-term benefits of sustainable water practices. They have both the resources and the will to invest in water reuse. The potential adopters are those for whom this is an attractive proposition, but they really need to see the business case and they have to have financial incentives. Now that's distinct from the profiteers, those companies who really only are focused on short-term benefits, to the point that even fines themselves might not be sufficient if the benefit, the financial benefit of using water irresponsibly or polluting doesn't exceed the fine. And sometimes they can only be forced into compliance by some sort of criminal penalties. And the last group are those industries who really don't have the financial tools or the know-how to do anything more than the survival baseline activities they're doing. Some of the sand miners in India, for example, or small manufacturers throughout the global south. We're really focusing as utilities on the early adopters and the potential adopters. Those groups have really 4 reasons to want to use water more responsibly, and in this case, to recycle water. This slide was put together by my colleague, Michael Skovgaard Jensen from Grundfos. We were at a panel together just 2 weeks ago down in Palm Springs on use of recycled water in industry. Water scarcity, if there really isn't enough water, and I know that Dr. Rao, I think, mentioned that a lot of the activities that for industry go on in places that are water stressed, and they need to consider the overall impact of their operations on the environment. Brand equity, this is where the consumers come in, where the ability of the brand to attract sales has something to do with certain consumers, with their environmental status. And if they're seen as bad actors, that could actually influence their ability to sell their product. Of course, there's always the floor, if you will, of regulatory risk, the need to comply. And then finally, just the cost of water itself can sometimes be a motivator. But any one of these at any one time may not be sufficient to get a company to make the kind of investment they need in water recycling. So the examples I'm going to provide come from the experience I had of managing the South Bay Water Recycling, which was a non-potable water system in the Silicon Valley area of Northern California. We eventually hooked up almost 1,000 different customers. About 10% of them were industrial customers. And of those customers, though, I think they use somewhere between 40 and 50% of the water, in part, as I think Dr. Rao mentioned, that the water use in industry tends to be more constant, whereas irrigation customers use water only in the summer, or when they need the water, and it's quite seasonal in nature. I think another thing we learned when we went out to the customers, it's interesting, there was a transition in the early stages. We went to companies like Intel and said, you can use our recycled water in place of your makeup water from potable, and you treat it anyway, so you can save $100,000 a year. And they responded by saying, well, that's great, but we have a system in place now, and if our line goes down, we lose $1 million a day. So the perspective of industry relative to their processes are really very different than the public sector. There's a very fierce protectiveness of the companies towards their profitability, an instinct avoidance of risk without reward, and a deep-rooted suspicion of government, all of which comes into play. The way utilities can respond to that is by helping to defray any costs associated with connecting to a recycled water system, being very clear about the risks and the benefits, and then being good partners to industries and providing timely communication and such. There was a report done by the Water Reuse Association about 10 years ago, looking historically at the use of recycled water by industry, in which they looked at some of the cultural differences between the companies and the utilities. For example, companies are looking to achieve profitability, and they're looking at cost benefit. The water providers, the public sector agencies, tend to focus really on their core responsibilities in terms of social benefits, and their time scales are usually much longer. They say that when the industry is looking at their watch, the utility is looking at the calendar. So they really need to be more focused on the timeliness aspect. There are also different measurements of success, like payback periods. Again, all this information is in the chapter, and I would encourage you to look at the book. The ways industries can be supported by utilities, in effect, it really addresses the cost. It's costly to connect to recycled water. You have to build a pipeline. You have to change if you're using non-potable water, the different systems have to be separated. There has to be backflow prevention. Sometimes chemical and operational treatments have to be changed. Utilities can support this change by underwriting the costs of connection and retrofits. Sometimes the discount of recycled water can be enough to attract the initial interest of companies. Other times that discount can actually be amortized into the cost of the construction. There's all kinds of financial strategies that can be used to make this more attractive. When it comes to the chemical treatment changes, I know we actually offered expert cooling tower technical folks to the companies to help them manage any changes to the chemical treatment from the quality of the water from the non-potable system. And with respect to the fact of having to shut down to make certain changes, it's important to acknowledge that there are risks to not using recycled water, in the sense that, especially in water short areas, recycled water can sometimes be a much more secure supply. And I know in California, where we'd ask companies, what's the cost if you have to reduce your water use by 20%? And then what's the likelihood that might happen in the next 10 years? Virtually no one said that there was no likelihood. So there are ways to frame the issue where you can monetize some of the benefits of recycled water that might not be immediately available, or immediately obvious, rather. Another way to look at this, this is also in the book, there's a charter system that looks at all of the issues that might arise between the public utility and the industrial customer. I know someone mentioned the West Basin, where they have regular meetings between the customers and the utility to iron out any issues that come up, but really to identify the stakeholders, the decision makers, be clear about the risks, and focus on the budgets and the schedules in a way that may be more aggressive than the utilities are used to. And everybody kind of signs on to this to agree that this is in fact what's going to be done. It's not a substitute for the trust that develops between the parties, but it can help document some of the decisions. So that's kind of a snapshot of how utilities can be better partners to companies to help make this happen. I'd be remiss if I didn't acknowledge that with respect to brand equity, really the cheapest things, the award programs, can sometimes be the most useful. Water reuse on a national level has a global industrial water reuse champion award, and even local communities often have green business programs that can be useful to helping a company understand their relationship with the society and how it can benefit them to be recognized for the work they do in water management. Last but not least, we're doing a sequel to the book called A Guide to Responsible Industrial Water Use in a Changing Climate. And we look at 7 guidelines that companies will follow who wish to use water more responsibly, beginning with treasuring water and recognizing that they have to work towards measurable goals with other people to share responsibility, and ultimately to commit to regeneration, because we don't want to just do things less poorly than we've done in the past. We really want to do things better. So again, thank you for allowing me to share some thoughts with you today, and I'd be happy to entertain any questions or comments.
I just want to share, thank you so much, Eric. I just want to share that Eric referred to a meeting in Palm Springs a couple of weeks ago in which he participated. And after that, I noticed one of the other participants posted on social media that every time you listen to Eric Rosenblum, you get you get a better, richer perspective. And I know that to be true. So thanks so much for being part of this today. Nichole Morris, Eric Rosenblum, two experienced professionals and leaders in this field. Thank you so much. To all of the attendees, I understand for a while we had a little bit of a glitch in using the Q&A function, but I think that should be resolved. So I'm happy to say I can start sharing some questions from the attendees. And let me see. Oh, okay. So this is, so there's a question for Nichole. This is particularly directed to you. And it's about the financial aspect of this. So how do you, as a company, how do you look at this, not just from a sustainability perspective and a resource conservation perspective, but evaluating the monetary impact, and is there cost savings, and have you documented that?
Yeah, and it changes for the different projects, of course, but in often cases we do see energy reductions. Because when you had, like, for instance, the Blue House, the water hub at RMEP, it saw a 50% energy reduction from the old aeration system because of the large blowers and things that were required to keep in that system. So we do see energy savings. In many cases, our facilities are already treating the wastewater. So the savings comes from pre-treatment of water or purchasing water. And it also is savings from discharge because we don't have to pay the city to treat the wastewater for us. So we typically do see a savings. It's not usually as large as we would see on energy projects or waste projects, but it's enough that we have enough ROI that we can do it.
Okay, thank you. Also, just real quick, Nichole, I had a question. You mentioned irrigation as a use, and I just didn't wanted to make sure that we clarified for people. You weren't talking about agricultural irrigation. I think you were talking about like landscape.
No, I was talking about landscape, and that's one of our critical that was one of our critical X's I mentioned, and our goal is to eliminate all irrigation. So we're going to xeriscape.
Yeah, because you have manufacturing campuses that
Yes.
have, landscaping on them, and rather than buying drinking water to pour onto your plants, you can use your recycling.
Yes.
Yeah.
And we do that we do that in several facilities, and our goal is to actually eliminate that as well, so that we're using it only in process.
Yeah, thank you, thank you. I have a quick. We have a couple other questions here in the Q&A. One is just about the sort of mindset and how do you start to break away from the water is cheap and plentiful to water is a precious resource to be taken care of. And this is for both Nichole and Eric, in the sense that Eric's closing slide talked about, the sort of value change, in a way. That's not your words, that's mine, but that has to occur. And Nichole, you were talking about sort of company culture and priorities. And so I think that mindset question is kind of a relevant question for each of you. Would you mind taking a stab at it?
I'll start. We started by developing a true cost of water tool, and it helped to identify all of the ancillary costs associated with water. Energy cost, pumping cost, maintenance cost, piping, treatment, additional treatment that may be necessary. And then when you start looking at that, it's about what we found is it causes your cost of water to almost triple from what you're paying from the utility. And So when you look at it from that way, you can see a true cost savings. And then also, we are unfortunate enough to have several case studies of sites having forced reduction in production because the utility couldn't provide enough water, or increased surcharges on sites because of the cost, because of disruptions in service and things like that. So when you start looking at the risk associated with a disruption in production, it's fairly easy to get a water project through.
That's a great point. Some of what you were saying reminded me of the chapter title in Charles Fishman's wonderful book, The Big Thirst. He has a chapter title called The Money in the Pipes.
Yeah.
And once you start thinking about the money in the pipes, it changes the way you think about things. Eric, quick response to that mindset question, and then
I
we're going to
think
move
the
forward
notion
with our next presenter, please.
the notion of the social value of water. I think Dr. Blatchley at the very outset of this talk mentioned that we didn't used to pay too much attention to electrical energy or water. There was plenty of it to go around. It was all about growth. And I think that that's a change that's happening. We chose for our indicator treasure water, not just the value from the monetary standpoint, but really to recognize, as we're beginning to see, how integral water is to all of our society. And we're beginning to understand that it's not unlimited. In fact, we have to use it more wisely. That's another example where I think utilities can step forward and place a higher value. It kind of galls me a little when situations arise, as Nichole mentioned, where the companies don't want you to conserve water because they depend on you, the revenues. They just assume you use more water, so you buy water for them. That has to do with the historically poor capitalization of water systems, where they pretend that you're buying water, but what you're really buying the infrastructure. So I think the way people change their attitudes for water is not just the industries alone, but when the communities begin to value their water, including creating more natural water systems that are visible, where people can appreciate water by having a part of the community. I think that's all part of the piece.
Going to give Chip Blatchley a chance to weigh in on this too, and then we're going to move forward with Heather TeGowan's presentation.
Yeah, thank you. I'll keep it pretty quick. I think we do need to sort of change our perspective. In a very real sense, in fact, I used to have a sign on my door that said, "We all live downstream. All water is reused." What has changed is that we're reusing water closer to the source of or point of discharge than we used to. But the reality is we have to reuse water. We don't have any choice. And again, all that's changed is that now we're taking water closer to a discharge point.
Well said. Thank you so much. So at the outset, I introduced two presenters from Stantec, Rob McCandless and Heather TeGowan. Heather is going to carry the load. Rob, we got a note, got called away on an emergency, and so we hope things are well, but we are glad to have Heather here. And here's a shift. You've heard us talk about, for example, with Eric's presentation and to some extent with Nichole's, about what that utility customer partnership and what can utilities do. But we also want to talk about what governments can do to facilitate greater uptake and greater adoption of industrial water reuse. Jill, did you want to, before we move forward, did you want to add?
Yeah, I was just going to encourage our panelists and presenters to answer questions in the chat as we go on here. I know there are some we haven't gotten to yet.
Right.
So this could be a chance for you guys to do that as well, because we can all see those fantastic questions and your responses. So please, as panelists, especially if you do have to jump off, feel free to answer some of those for us.
Much appreciated. Thank you.
Thanks, Bill.
All right. Heather, we can see your screens and we can hear you, so it's all yours.
Thank you. Yeah. So also to preface, I am not a lawyer. So I am a PhD in environmental engineering. So I come from that perspective, talking about the policies and legal frameworks. So one of the biggest things I think, and specific to the Indiana market, I'm in Arizona, so I'm in the peak of drought and needing reuse here, right? But wanting to step through some of the drivers for, again, and one of the Q&A comments was apt for this. What are the drivers in a theoretically water-rich environment, right? And how do we really incentivize or demonstrate the need for this? And a huge part of it has been touched on by all the other presenters in the corporate responsibility, sustainability pieces of it, and also just providing a long-term water supply to people who actually live there and are not necessarily the entity that is receiving or benefiting from the water that's being used in their neighboring areas. So we'll talk about how other states are managing industrial reuse and then some of the key legal framework items. So we've been looking into what's on the books in Indiana and then what kind of carry forward items there are. So a few roadblocks and a few opportunities there as well. Okay, so what are the drivers? So obviously there's large scale development going in across the Midwest. There's historical, huge scale industry, manufacturing. There's a whole list of things that we'll talk through a little bit. Trying to come up with better interagency and like regional thought processes, right? So it's not about me and my watershed and my one well. It's now about how am I taking water from other places and then maybe restoring that back, or am I trying to offset some of that water lost to those freshwater resources, right? Optimizing the use of the water. So again, once through to many times through many different uses, right? The uses can evolve as kind of that water is used in different ways. Obviously, we're not going to drink straight from the pipe that's coming out of the toilet, but we have plenty of technology and different ways that we can framework all of those different pieces together, right? And then how does that translate into actually having regs on the books that this can be done in a way that stewards the environment and stewards public health as well. So what are our business case, right, for industrial reuse? And we've talked about a lot of these. Water security is a huge one. So if you're in an area that doesn't have any other supply but groundwater, like we know that groundwater is ultimately a renewable, slightly water supply, but you ultimately have a finite amount of water in the ground. And if you're not replenishing that and restoring that, eventually you will come up with empty wells. It reduces infrastructure costs. So I put an asterisk there because that can be misleading in some ways, right? So there's offsetting certain infrastructure costs. There will be infrastructure required and needs to be built in order to implement these sorts of systems. But instead of maybe putting in a 25-mile pipeline, you can put in a half-mile pipeline to get this water from somewhere else to a new location instead of going from a raw water resource to a potable water supply, right? So using potable water and then continuing to recycle it keeps it in a smaller footprint, especially in these larger industrial complexes. Supporting sustainability goals, so that's top of most companies' agendas these days. If you're in a publicly traded company, I work for Stantec and we're one of the biggest, we're always high on the list of sustainable firms, right, that do what we do. And there's a reason why we're chasing after those things, right? Like we don't use water other than in our typical office settings, but we're still trying to be net zero water and water positive, even as an engineering firm. So if we're doing that, the scale of potential benefit as these larger data centers, semiconductor, right, all of the key manufacturing facilities, it really can make a cumulatively huge difference. And as well, just supporting environmental compliance. So I think what Eric referenced in terms of the different levels of people who are excited about this versus the maybe more bad actors. In general, reuse can support environmental compliance because you will be at least lessening the amount of that water that's discharged into public water bodies that has not had higher levels of treatment, right? So kind of going the step beyond those just baseline NIPD's permit requirements. So how are the different ways? So there's going to be a few different lists we kind of go through. So I live in the Phoenix Metro. We have the largest nuclear generating station in the country, the largest, I think, potentially in the world that is inland, right? We don't have a source of water. So they're using 100% secondary treated effluent from the wastewater plant in the middle of city of Phoenix that sends out about 60 MGD per day to this cooling operation down at the nuclear generating station, right? And that is every day people flush their toilets. Every day there's a guarantee. So the plant is treating about 140 MGD. So they're sending 60 to that, to the nuclear generating station. And again, that's for cooling, and they are using it. They're not using it through a one school. They have multiple cycles of concentration. So they're getting multiple reuses of that reused water, right? So kind of stepping through those different pieces there. Wash down and rinsing, we've talked about some of these other ones, right? Obviously, contact versus non-contact is a huge deal if we're using domestic sewage mixed wastewater. If it's going to be purely processed water, then you can kind of step that down a little bit differently. And source separation is really huge if you want to optimize your water reuse in an industry setting, right? So you can separate, okay, all of the like kitchen and restroom waste can go to this domestic treatment area versus having the processed water separated. So you have a lot less treatment required when it's just commingled. So again, forward thinking, putting that in on the front end of some of these being installed. Less common is direct evaporative cooling, and that is something that they're currently pushing for at a large industrial entity in northern Nevada. And that is because direct evaporative cooling has personnel, right? Employees are exposed, as well as that is being directly evaporated, and there is potential for human contact. So the biggest risks there are going to be on the pathogen side of things, right? Those are very low concentrations. We in Arizona use it for snowmaking. So if you're out and about in northern Arizona, you can take a ski slope that is made of reclaimed water. And again, it just varies on how, what the level of public exposure is, how we're going to treat that on the treatment side of things. So all of these different industries are currently practicing reuse across the country. Obviously, within different states, there are regulations associated with what this looks like, depending on what the influent water is. Indiana is still in the process of moving in that direction. So that is something that we're looking forward to, is having more guardrails around what that can look like. But again, data center, semiconductor, all of the major water hogs are going to be on that list of entities that really are trying to implement ways of reusing water, whether internally to their own processes or taking reclaimed effluent from municipal wastewater treatment, like Prakash was saying earlier. So in terms of the footprint, right? So across the Midwest, and this is from the Water Reuse Association, this is the breakdown of different industries. And so this is kind of how many different possible users are available, right? So across that kind of Midwestern and Great Lakes region. So in terms of what are the limitations, we'll kind of step through this. So this is where we get into more of the regulatory piece of this, right? So we have a natural system, we take raw water out of it, whether that's groundwater or surface water, take it to a water treatment plant, then send it out to the industrial entity. They can use it. They will typically then discharge it after pre-treating it, right? So they have to do some sort of pre-treatment before it can go to a wastewater treatment plant. And that's part of that Pollution Prevention Act, that PPA, before it goes to a municipal plant. And then typically that NIPD cycle carries us back to a natural system. In order to implement, just policy-wise, we need some sort of catch to have a legitimate permit, right, to say what is acceptable quality for me to send back to industry. And again, that varies state to state. We'll talk through some of the specific parameters that we typically look at on the next slide for different states. And as well as potential opportunity here, right, to have a permit going between different industrial entities. So my wastewater effluent could be used, right? If I'm a pharmaceutical manufacturer, I can then use that wastewater instead of sending it to the municipal plant or sending it to a river. I could send that to cooling tower A, right, at a different industry. And it requires the permitting and legal agreements in order to do that. So I think it's setting up the framework, right, that we can take that water cycle and create a do loop over here instead of all of that water being discharged to the natural system. Again, needing to maintain natural systems. And I think that was one of the questions as well. So factoring all of that in, and obviously there's EPA and state EPA related items that will be stewarding that water well. So skipping ahead, and this is going to be a quick flash slide because I know there's a lot on here, but something to kind of keep for later is all of the different levels, right? So this is specific to cooling towers. So if you do use reclaimed, so wastewater effluent, municipal wastewater effluent for cooling towers, there's different levels of treatment that's required, right? Virginia, so not too far from Indiana. Secondary treatment, disinfection, and then they have specific bacteriological requirements, right? And so that's going to be a non-contact. Then level 1 is going to take that a step further, right? So this is more of a case where you have potential exposure to employees, you have potential exposure to the public through that being evaporated out. California likewise has pretty similar. They require disinfected tertiary to even put it into a cooling tower. And you can see these 5-log removal for viruses. So again, California always leaning more on the stringent side. And then Nevada and Arizona both allow Class B. We also have category A plus, and Class A plus, and A above that for both Nevada and Arizona. So again, this is the minimum required standard, and you can kind of go above and beyond that with the domestic effluent that's treated. So I guess in terms of what's needed is first establishing a regulatory authority, right? So at the state level, there needs to be authority to have responsibility for permitting, monitoring, compliance. On the local level, needing to have authority for that individual utility that's going to be receiving whatever wastewater flow, right, is coming back. And that could be cooling tower blowdown water, right? Having pre-treatment on that adequately to protect their wastewater treatment plant, right? So again, keeping that cycle controlled and at least managing those relationships, right? Always emphasizing that stewardship is the priority, right? So number one job of any environmental agency, as well as any environmental engineering people, protect health of humans and the environment, conservation and anti-degradation. So that's mandate from the Clean Water Act, right? Safe Drinking Water Act, all of the different pieces that we're trying to protect all of the bodies of water around us. And then trying to keep, and this is maybe more of my personal push here, but allowing industrial users and utilities to stay in their respective lanes, right? So you have water that you're creating fit for purpose. So do I need potable water going into a cooling tower? No, I don't. Do I need high enough quality water that I can get high numbers of cycles of concentration on my cooling tower? Yes. Am I providing water that's a certain quality that once it goes into industrial entity A, they are going to treat it anyways to a much higher standard for whatever process they're going to be using. And that takes the responsibility off of the utility onto the industry, right? So allowing them to do their fit for purpose interior treatment, as well as some of those different wastewater processes, kind of what Nichole was getting at. So again, they're responsible for on-site polishing. There's a minimum standard of water that's being delivered to them and keeping up with that. So another piece of that is classifying my reclaimed water, right? So I can't just be like, everyone gets whatever comes out of the wastewater plant. So this, again, key parameters, and Chip talked a little bit about this as well, but different categories mean different things, right? So you're going from like lowest quality to highest quality, type 1, A plus, disinfected tertiary, right? It just depends on where you are, what they call it. But basically just certain treatment technologies may be required. We might need nitrogen treatment. We might need phosphorus treatment, right? On the wastewater side, definitely disinfection, as well as some amount of turbidity management. So those are kind of your key things. And again, at the state level, putting it out there, like this is what we need as a baseline. And then whatever is negotiated between those different entities or between the state and the utility can then be what's taken forward. So how do we then take this? So this is kind of the side by side here, right? So we have the state classes of effluent, and then what can we actually use them for? So I don't know why it's trying to search there, so I'll just, sorry about that. Restricted access versus open access, right? So if I'm going to be in contact with other, with employees or with the public, we're not going to be using this, right? So this is how in these states, this is categorized, right? So firefighting, do I need sprinklers in my giant industrial building? We don't have to use potable water to do firefighting. A lot of states use non-potable water, right? Like a wastewater plant has a whole supply of non-potable water that they can use as fire protection on site, as long as it's treated well enough. And so, and then stepping from commercial food crops, right? So my food's food to my food, right? If we're treating it well enough, we can put it on commercial food crops. We can use it for access landscaping that's going to be at the park where my kids play or school grounds, right? All of those different levels. And again, industrial has the same fit for purpose sorts of needs. Their needs are obviously very different than green grass where you can play soccer. But again, thinking through these different pieces of, do I need wash down water? Is it processed water that's going into a very fine, like highly tuned system, right? For a semiconductor process or pharmaceuticals, like we want that to be ultra pure water. And so maybe there's different stage gating on what can be used where, right? And that goes into to how you categorize. So a few success stories. I know we're low on available time left, so I'll be brief, but I know Intel was mentioned earlier. I will hype them up on the Chandler side of things. So they've been a huge partner of the city of Chandler for the last 15 years. They have a brine reduction facility. They're paying into the wastewater side of things. They're taking reclaimed water as part of their source water. And so that's part of their like 3.3 billion gallons of water saved from Chandler's plant, only Chandler, in 2022, right? So that's a huge savings both to the city needing to find more water resources to fuel this large fab, right? Producing semiconductor, right? And they're up to a platinum level of sustainable like Alliance for Water Stewardship, right? So first semiconductor company to do that. And that's because of their Intel Ocotillo brine facility plant. So again, Loudoun County is one closer in Virginia. Obviously I talked about Palo Verde, and then our golf courses have actually partnered. So this is heavy industry, right? But more of a different sort of commercial, because the water is so saline in the Phoenix Metro, city of Scottsdale, and amalgamation of very high-end golf courses, including PGA playable golf courses, now use highly treated effluent so that they can not kill the grass. So they paid into, like the golf courses paid in to have RO at the wastewater plant so that they don't have high sodium because it doesn't keep the grass green. No one wants brown golf greens. So in terms of some of these roadblocks and how we really overcome those in terms of the policy side, the quality, I think, is the biggest public facing problem. I think it's to some extent becoming less of a problem in certain industry applications, but are you getting something as is? Is it better or worse than the muddy river down the road, right? There's some things that it's already been treated to potable quality and then it's been used. So there's some benefits with not retreating raw water and kind of moving on with that. You also will get improved effluent quality from the wastewater plant because there's going to be that partnership of trying to figure out what quality needs to be leaving that. Regulatory agency, so new regulations in the state. And obviously, Indiana needs an Indiana-based approach. Like, you cannot pluck things out of Title 22 and just say, thou shalt be California now. Like, no one, right? Like, there's certain cultural norms that need to be managed as well. And that's kind of that last one there. So cost of service is a big one. So partnering the utilities with industry, so it's not all falling on the taxpayers and the utilities to cover the cost of some of that additional treatment. And this is because Meta just announced their giant efforts in the central part of Indiana. Is every large water using company, for the most part now, has a sustainability report, and water stewardship is a huge part of it. So by, I think they say water restoration at the watershed level, it's at the very bottom in tiny font. We will restore 200% of consumption in high water stress areas, right? So that is a goal that they have. If they're in a less water stressed area, they'll just do 100%, right? So, but they're still trying to net zero on that water. So looking at the opportunity here, and these are big dollars, and this is the Water Research Foundation, so don't call me on having these numbers exactly right, but millions of dollars of potential benefit from using industrial reuse, and this is the dollar values across those different sectors. So the Water Research Foundation put out a like report on the Midwest specifically, so you can find that. I can always drop it in the chat as well. But you can see cumulatively, right, by the 2030s, we're looking at significant sums of money that can potentially be saved and reinvested elsewhere if we're starting to use municipal and industrial reuse across the Midwestern region. So with that, any questions? Happy to answer. Rob did contribute to these slides, even though he is not present. So if you want to email him, I totally understand, or you can reach out to me. But thank you.
Thanks so much, Heather. And we have about 5 minutes remaining. There is, I'm going to toss this question to you, Heather, but it could also be responded to by any of the other presenters because you all might have perspectives on this. From a stream flow perspective, how do we think about wastewater recycling and reuse? Do we think about it as there's going to be less treated wastewater discharged to the stream because we're reusing it, and therefore it's going to have a diminishing impact on stream flow? Or we're taking less water out of the stream because we're reusing it, and therefore there's going to be more water available for stream flow? Anybody have a potato response to that?
So I have a couple of thoughts on that. And I think it varies based on the industry that is taking or reusing water. So if you're in a heavy cooling intensive industry, that water is lost to evaporation. So that will not be recycled. Like, it will be offsetting raw water from the river that would be taken out initially.
Right.
But it will not be improving by any stretch the return flow to that river. Which, again, maybe that water that's being not returned to the river now means the river has a higher quality, right? If there were impacted, if there's higher nutrients that were being discharged to the stream, maybe we're improving that ecosystem by not discharging certain types of industrial effluent to them. But yeah, on a cumulative volume basis, I think that remains to be seen, and it's definitely site specific.
Okay, thank you. Any of the other presenters want to talk about that? I am going to do a quick screen share. We do have a couple more questions in the Q&A, but I'm afraid in the interest of time, I need to just do one thing real quick. I actually need to do two things real quick. First, I need to thank our fantastic presenters. Linda Dahman, our colleague at Purdue, said what an all-star lineup, and boy, was that true. Second, this is not your last chance to listen to these presenters. We do, as you may have heard at the beginning, we record these forums, and our Purdue partners have a YouTube channel where you can see the previous ones. And also, I noticed that Water Reuse Association and Water Environment Federation, two of the professional associations in this field, are co-hosting a conference not too far away in Columbus, Ohio this summer on industrial water reuse. So I just wanted to put that up there so that any of you who are interested could make a note of that. I want to just give Lynn Dahman and Jill Hoffman a chance to say thanks and farewell before we conclude. Lynn?
Yeah, thanks very much. I think this was really useful. And just as a call out, I put the link to our YouTube page in the chat, and you'll also find there one of the many webinars we have is on water withdrawals, transfers, sustainable use and policy in Indiana that we did with White River in April of 2023. So it's a nice compliment for anyone interested in the, more on the Indiana side. And definitely we will have this up, and it was a very, very excellent contributions by our panelists. Thank you very much for your time.
Yes, I won't keep you too much longer. Just also wanted to echo the thank you to our panelists, but also to the participants. I'm always encouraged when we do these to see what a deep bench we have in terms of water professionals, those interested in water conservation or economic growth or quality of life aspects of water management. So in addition to the stellar presenters, quite a stellar list of participants with really good questions. I just encourage the panelists, if you have a minute to answer those questions in the Q&A, that would be great. Otherwise, we'll do our best to follow up with anything that was lingering with you guys. And again, thanks for participating and being engaged. And we will see you at the next forum or at the Water Summit, or before then at a Water Summit working group, or however you're involved in these conversations. We really appreciate it. Thanks, Bill.
Thank you all. Yes, we'll see if we can maybe hang on for a couple of seconds. We'll let the attendees exit if they wish, but we'll see if maybe we can type out a couple more answers to the Q&A before we go. Thank you.
I'm so curious about Oliver's question there on ASR, but I don't know that we have an answer for that for you, Oliver, but.
Oh, California and Arizona all over it, right?
Right.
Yeah, so aquifer storage and recovery, I can speak to that a little bit. And this is, yeah, I don't know if this is the opinion of the firm or my opinion, but we'll just leave it there. But in terms of aquifer storage and recovery, there are obviously significant benefits to getting recharge like back into the local watershed, right? There's a lot of benefit for that. There's also limitations, right? So in certain areas, and I know even within the state of Indiana, right, there's high iron and manganese. So if you treated that water for iron and manganese and then you send it through the cycle of, right, municipal water cycle, and then you put it back into the ground, it probably doesn't have the iron and manganese that now you're reintroducing it to. In Arizona and other more desert states, we have nitrates, we have arsenic, chromium, right, that are all going to be coming into contact with that water that we're recharging. And so I think there's definitely a time and a place to do aquifer storage and recovery. And part of that is just banking water so that you have available potable water supply for the future, right? That's a sustainability like of the utility initiative. Like in Arizona, we require 100-year assured water supply. And that means you have to be able to have, for your subdivision to be platted, you have to have 100 years of water on the books, whether that's groundwater or surface water. So places that only have groundwater, that's the only way they can meet that, is putting water back into the aquifer. Direct reuse cuts out a lot of the It adds more treatment to some extent, right? Because it is wastewater, but it also bypasses some of the redundancy, I guess, is part of that. Like we're not doing the same thing twice and pumping it into the ground and pumping it out of the ground. There's some energy associated with that as well, but just some thoughts.
Thank you. Anybody else want to follow up on that? I
Thanks,
think we're
Heather, and thanks for
pretty close to
taking-
clearing the queue on the Q&A too, if you'll pardon the double use of the queue there. All right.
Good, Bill.
Wasn't
you,
intentional,
guys.
but you know.
Nicely done. Okay, well, thank you, team.
Thank
We
you
will-
all.
Thanks
All
as
right.
always.
See you
Thank
next
you,
time.
everyone.
Bye-bye.